Hello everyone, welcome you back for the CNC milling. In the case of the computer integrated manufacturing, you have to learn the two different types of part programming. One is with respect to the turning by using the lathe machine tool. The second one is with respect to the milling by using the milling machine tool. In this session, we are learning the programs with respect to the milling machine. As we know that milling machine is a versatile machine tool. The milling machine is called as a versatile because here by using the milling machine we can do so many different types of operations, like either it may be a milling or it may be a gear cutting or drilling or boring, and even the reaming and even the contouring operations can also be done by using the milling machine. The major difference is we have to use the different types of tools, either it may be a cutters or it may be the end mills. The milling machine can be programmed on the 3 axes, especially in the sim lab, but in a realistic or it may be in the industrial application, X, Y, Z. Along with that, if there is a table rotation is also there, even ABC can also be, it is possible. These type of machines are the robust machines, but at present we are learning only with respect to the XYZ movement. X-axis control the table movement, either it may be left or it may be a right. The Y-axis controls the table movement towards or away from the column, and the Z-axis controls the vertical movement of the knee or the spindle. See, this is a small introduction with respect to the milling machine. Now the XYZ is represented either by using with respect to the machine tool itself or by with respect to the workpiece and as well as the tool. The tool movement with respect to the workpiece is if the tool is moving to the right side from the origin, we are considering x direction, that is nothing but the positive. If the same thing, if it is moving towards left side from the origin, we are considering that x direction as a negative. In the same way, if the tool is moving away from the origin, we are considering that as a y direction, and if it is towards and if it is from the origin, if you are considering means, then we are considering that y-axis as a negative. Then with respect to the z-axis, if the z-axis movement, if it is upward, we are considering it as a positive, and if the same thing is moving downwards, it is considered as the negative. Now here before going into the program, there are 3-4 different parameters we have to know and we have to learn with respect to the reference point. The first thing what we are referring or we are learning is nothing but a machine 0 point M. This is specified by the manufacturer of the machine. This is the 0 point for the coordinate system and the reference point in the machine. The machine 0 point can be the center of the table or the point along the edges of the traverse range, which is as shown in the figure. See here, the precise position of the machine 0 point is always it may be at the center of the what we can say the table itself. Depending upon the type of the machine, even this what we can say the machine 0 point will also vary. The next point is nothing but a reference point. This point serves for the calibrating and for controlling the measuring system of the slides as the tool travels. The position of the reference point is accurately predetermined in every traverse axis by a trip and as well as by means of a limiting switch. Therefore, the reference point coordinate always have the same and as well as precisely known as a numerical value in relation to the machine 0. Now the next point is nothing but the workpiece 0 point, or the workpiece 0 point is a point that it can be determined on the workpiece coordinate system in relation to the mission 0 point. The workpiece 0 point is chosen by the programmer and the input into the CNC system when the setting up the machine. The position of the workpiece 0 point can be freely chosen by the programmer within the program piece envelope of the machine. Now here in this case, these are the three different types of points. Normally any machine tool will have either it may be a machine 0 point, or it may be a reference point, or it may be a workpiece 0 point. Normally while doing the program, we are going with respect to the workpiece 0 point only. The next part what we have to learn is with respect to the two things. One is with respect to the absolute dimensioning, the another one is with respect to the incremental dimensioning. The absolute dimensioning system is always refers to a fixed reference point in the drawing. This point has a function of a coordinate 0 point. The dimension line runs parallel to the coordinate axis and always starts at the reference point. The absolute dimension is also called as the reference dimension point. The another dimension normally what we are referring is the incremental dimensional system. When we are using the incremental dimension system, every measurement refers to be a previously dimensioned position. The incremental dimensions are the distance between the adjacent point. These distances are converted into a incremental coordinates by accepting the last dimension point as the coordinate origin for the new point. See, in most of the programming, normally we are referring with respect to the absolute programming only, or the absolute dimensioning system only. Incremental dimensioning systems, we are not at all using it. The figure shows the two different types of what we can say the programming, or it may be a dimensioning. Either it may be with respect to the absolute dimensioning and as well as the incremental dimensioning. The first one, or it may be the top one. The P1 is refers to 0, 0, and if you go to the P2, the x direction what we are moving is of a 20, and the y direction it is 0. And again P3 is nothing but x direction is 20 and y direction is also 20. Now this program is nothing but this type of dimension what we are referring it as the absolute dimensioning. The below figure shows that the P1 is referring it as 0, 0, and again if you go to the point P2 there also it is x is varying it, but only the y is not varying. 20, 0 it will be. Then again if we go to the point 3, which is nothing but a P3, there what will happen? Only x is not varying it, y is varying it. As x is not varying it, we are considering that as a 0, and as a y is varying it with a dimension of 20 mm, we have to give that dimension as 20. Then the point P3 is as 0, 20. This type of dimensioning is nothing but the incremental dimensioning. Now the next part what we are discussing is with respect to the different types of codings normally what we are using in the case of the milling machine. See, the different types of codings normally what we are using is the G code system and as well as the M code system. G code systems are called as the preparatory function codes, and M codes are nothing but the miscellaneous codes. The G00 is nothing but the rapid traverse, or it may be the positioning. See, the positioning in the sense, if you are in the programming after completion of the machining, it has to go to the reference point, or it may be a machine point. That moment it can be given by using the G00. G01 is nothing but the linear interpolation, which is nothing but the feed. G02 and G03 is nothing but the circular interpolation. The G02 is referring with respect to the clockwise, and G03 is with respect to the counterclockwise. G04 is nothing but a dwell time. and G20 and G21 is with respect to the dimension. G20 is with respect to the inch data input, and G21 is with respect to the meters data input. G28 is the reference point return. Reference point return in the sense it's not with respect to the machine reference point, it's the reference point with respect to the workpiece. Now G40, G41, G42 are the two tool nose radius compensation preparatory functions. G40 is with respect to the tool nose radius compensation cancel, and G41 is with respect to the tool nose radius compensation to the left side, and G42 is with respect to the tool nose radius compensation to the right side. See, once if you start programming it, the cutter what we are using is nothing but the end mill. In this end mill, once if you give the 0, 0 means that 0, 0 is referred with respect to the center of the cutter. With respect to the center of the cutter, and as well as movement of the cutter to the right side, to the right side, we are considering that as the tool nose radius compensation, which is nothing but G42. If the same thing, if it is to the left side of the cutting tool or the cutting path, then we are considering it as a G41, the tool nose radius compensation with respect to the left side. The G43 is nothing but the tool length compensation direction, which is for the positive side, and as well as the G44 is a tool length compensation for the negative direction. The other G73, G74, G76 are with respect to the different types of operations. Normally what we are doing in the case of the milling operations. If you are doing the boring operation, in that case we have to go for the G76, and if you are going for the drilling cycle, or it may be something like a spot boring, or it may be a drilling cycle, or it may be a counter boring, then we have to go for G81 and as well as the G82 as the codes. The next some of the codes are G90 is nothing but the absolute command. This is the most important one. How the programming what we are doing it, either the programming is with respect to the absolute dimensioning, or it may be a incremental dimensioning. If the programming is done by using the absolute dimensioning, then we have to give it as the G90, and if the programming is incremental, then we have to give it as G91. G92 refers the programming absolute 0 point. G94 refers to the feet per minute, and G95 refers to the feet per revolution. G98 refers to the return to the initial point in the canned cycle, and G99 is a return for the R point in the canned cycle. The next topic what we are discussing is with respect to the miscellaneous, or it may be miscellaneous codes. The miscellaneous codes are with respect to the what we can say indirectly the operations of the particular type of the machine tool. M00 is nothing but the stop programming. M01 is nothing but the optional stop. M02 refers to the programming end. M03 refers to the spindle forward. M04 refers to spindle reverse, or it may be something like a forward and as well as reverse. M05 refers to the spindle stop. M06 refers to the tool change. Even here also, while doing the tool change, the type of the tool what it has to be selected, it has to be specified. M08 refers to the coolant on. M09 refers to the coolant off. M010 refers to the vice open, and M011 refers to the vice close. M13 refers to the coolant spindle forward, and M14 refers to the coolant spindle reverse. M30 for the program stop and rewind. M70 is for the X mirror on. M71 is with respect to the Y mirror on. M80 refers to the X mirror off, and M81 refers to the Y mirror off. M98 subprogramming call. M99 is subprogramming exit. See, these are the miscellaneous code normally what we are using in the different different types of program when we are manufacturing a different types of component.